Hello, welcome to my channel. Once again, we are continuing with the tutorial on linear programming. We are taking the aspect that deal with the word problem, and we are on the episode number 10. So the question here we want to deal with is a small dog house requires 8 feet square of plywood and 6. This is of 6 feet square of insulation. So a large dog house requires 16 feet square of plywood and 3 feet square of insulation. Only 48 feet square of plywood and 18 feet square of insulations are available. So if a small dog house, this is dog, small dog house sells for 15 Ghana cedis and a large dog house sells for 20 Ghana cedis. Then how many dog houses of each type should be built to maximize the revenue and to satisfy the constraints? If you follow our tutorial so far, you know if you have a word problem in this form, you look out for the commodity you represent by the variable x and y. Now, when we identify those commodities, we can see that we are dealing with dog house, large and small, which each of them requires a plywood or insulation. So we are going to use that to generate the inequalities that we require. So from here, we are going to generate the table in this form as in identifying our commodity. We have small dog house represented by the variable x. Then the large dog house represented by what? The variable y. Don't forget, we are looking for plywood and insulation. So the plywood needed for the small dog house will be here. The insulation needed will be here. For large will be here, and the insulation. Then their total, the total available plywood and that of the insulation will also be here. So let's fix that out of the question and see. If you check, the small dog house requires 8 feet square of plywood. So at this point, we are going to indicate the 8 feet square here, which are going to be in the same unit. Then it requires 6 feet square of insulation. So we indicate the 6 also here. When it comes to a large dog house, we are using 16 feet of plywood. So we have 16. Then 3 feet of insulation. So we're going to have 3 feet of insulation. Then only 48 feet square of plywood are available. Meaning, in doing the large and the small, we need only 48 feet square. Then 18 feet square of insulations are also available. We are going to have 18 as total. So from this, we can now write the inequality that we are looking for. Don't forget the available plywood is 48. It doesn't mean that we should use all the 48. It could be 44, it could be 40, it could be 30, provided the feet measurement is okay. Which means that if I take x of 8 or 8 of x, then I'll be taking 16 of y. All must be within the 48. I cannot use more than 48. So the inequalities become 8x plus 16y should be less or equals to 48. Okay, this will be the first inequality. 8 of x, 16 of this should be equals to this. We can finish it, or we can do less than 48. So if I simplify this, this will give you x plus 2y less or equals to, you're using 8, so 6 become the first equation. Then in the case of this insulation, we have 18 feet available. The same way we can use all the 18 or less than that. So I'll be having 6 of the insulation for the small house, then 3 of the insulation for the large house should be less or equals to 18. With 3 being the common factor, I can have 2x plus y less or equals to, when 3 go here, that will be 6. So we have the second inequality. So don't forget, these are the two inequalities we can get from the question. But we have also a natural inequality we can write, which will be x will be greater or equal to 0, and y will be greater or equal to 0. So these are the 4 inequalities. So now we are going to convert the inequalities back into equation in order to find the intercept on both axes. So the first one is going to be x plus 2y equals to 6. The second one is going to be 2x plus y equals to 6. Then the third one will be x equals to 0. Then y equals to 0. We are only removing the inequality sign and replacing them with the equals to make it an equation. So taking the first one, for x plus 2y equal to 6, if I'm finding the intercept on both axes, I will say when x is 0, y will be equal to what? You know, when x is 0, you'll be having 2y equal to 6. Dividing both sides by 2 give you y to be 3. So y become 3. So therefore, the point we are going to plot will be 0 on the x-axis, then 3 on the y-axis. Then, when y also becomes 0, meaning we are looking for the intercept on the x-axis, then your x will become, y is 0, so x become what? 6, right? That is for this equation. Let's take the second equation, which will be 2. So for 2x plus y equals to 6, when x is 0, I think we need to write a point for that one. So the point we are going to be using is 6 on the x-axis. 6 on the x-axis, 0 on the y-axis. So for 2x plus y equals to 0, when x is 0 here, y will become what? 6. You can see when you make this 0, you will let y equal to 6. So therefore, the point will be 0 on the x-axis, 6 on the y-axis. And when y also is 0, what will be x? Y is 0. X will become 2x equal to 6, where 2 divide to give us 3. So our point will be 3 on the x-axis, 0 on the y-axis. Don't forget, here will be the origin. So 0, 0. We locate the 0 on the x-axis and the y-axis, draw a line through it. Alright, so now we are going to use this point to draw our graph. So because we are not having any negative values, we can have our graph in this direction. So what are we going to do? We are now going to locate the first point, 0 on the x-axis, 3 on the y-axis. So we know 0 is here on the x-axis, then 3. Then we also have the next one, 6 on the x-axis, 0 on the y-axis. So 6 here. All these points are coming from the same equation. So that gives us the straight line we are looking for. So that is going to be the straight line with the equation. Okay, let me finish drawing and indicate to see where I'm going to put it. Then for the second one, we locate 0 on the x-axis, 6. 0 on the x-axis, 6 on the y-axis. So we have it there. Then we locate 3 on the x-axis, 0 on the y-axis. So 3 is here. We also draw a line through that to form the next straight line. Okay, so now I can write my equations. The first one was x plus 2y equal to 6. That's the first straight line. The second straight line is going to be 2x plus y equal to 6. The next thing to do is to draw the line for x equal to 0. which means you're looking for a line parallel to y-axis, which means the y-axis itself. Then y equals 0, looking for a line parallel to the x-axis, which will be the x-axis itself. So x-axis is part of the polygon, y-axis is part, this line and this line. So the region that is going to be included, that will satisfy the solution, is going to be this. And in locating that, we also need to find the vertices. So we have A, the corner here, B, C, D. When we locate the vertex of the polygon, picking the point from there, putting it back into the revenue constraints that we were given, we can be able to see how we maximize the cost when we have 15 cedis and 20 cedis for small and large respectively. So for the second part, we can pick it from here. We are looking for the revenue. So if a small doghouse sells at 15, meaning 15 of the x for doghouse, 15x, and the large doghouse sells for 20 of the y, how many dog houses of each type should be built to maximize the revenue? Don't forget, maximize. To find the maximized or optimum value, we are only going to locate the vertices and put in the point into x plus y. In this case, the x is having a coefficient of what? 15. Then the y is having 20 as the coefficient. So when we locate the point here, substitute into that expression, that will give us the maximum value. So in this case, we are going to put those points into this table. The vertex, the point for x and y, then we substitute for the revenue formula. This is the revenue formula. We look out for the maximum one. Then we know the number that we can make in terms of small and large. So locating the point at A, vertex A, we know 0 on the x-axis, 0 on the y-axis, 3 on the x. So 3, 0. Meaning I'll be having A to be 3, 0. The B is the origin, so 0, 0. 0, 0. Where is the C? 3 on the x-axis, 0 on the x-axis, 3 on the y for C. So 0, 3. Then this, we can have 2, 2. If we check very carefully, if you don't know where to easily identify the point, you can solve these two lines simultaneously. So the answer, the solution becomes the point of intersection. It will be the same as the one if you use the correct scale to draw the graph. So now let's see. For this 3, 0, meaning 3 times 15, 45. 45 plus 0 will give us 45 Ghana cedis. Let me just write 45 without the CD. 0, 0, right? That will still give you 0. That's Ghana cedis, right? 0, 3. 0 here. Then 3 times this will be 60 Ghana cedis. 2, 2. 2 here will be 30, right? 2 here will be 40. And then 2 times this will be 30, 40. We have 70 Ghana cedis. So you can see clearly that the maximum value is 70. So to maximum the cost, the revenue, it means we must build 2 of the small dog house, and don't forget 2 is a y. 2 of the large dog house. If you want to maximize the cost. In this case, you see that when we don't build any of them, the revenue is going to be 0. But when we want to maximize the cost, then we need to be able to build 2 of the small one, then 2 of the large one. That gives us the actual optimum value we are looking for. So the maximum point will help us to identify the number of the x and the number of the y to build in this question. I believe with this tutorial so far, you can be able to gets a little understanding of linear programming in word problem. Thanks so much for watching. Share, like, and comment. Bye bye.